Good evening to all. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kyapuram, Bangalore. Today I am going to discuss about third session of Mathematical Concept for Chemistry, which belongs to first semester BSc, affiliated to Bangalore North University. In this session, I have to discuss about differentiation. Now, objectives of this session, we have to know about meaning of quantity, dependent variable, independent variable, function, and differentiation. We have to also know about rules for finding the differentiation. Again, we have also solved some problems on differentiation. Again, we have to know about maxima and minima, meaning, and condition for maxima and minima, and some problems you have to solve on this maximum and minimum value or maxima or minima. Again, we have to also explain about partial differentiation. Then lastly, we have to also know about what are the applications of partial differentiation in chemistry. These we have to study in this session. After completion of this session, you come to know about the meaning of differentiation, rules for finding the differentiation, you familiar with maxima and minima value. Then also you have to familiar with partial differentiation. Then also you have to application of partial differentiation in chemistry. This you have to come to know, or you have to gain the knowledge, these knowledge after this completion of this session as outcomes. Then before discussing this session, you have already known about the basic knowledge of differentiation and first principle method of differentiation, because in the derivation or making the formula you have to apply that is a first principle method. No, therefore you aware about that is a first principle method in differentiation. You have also known about partial differentiation in PUC second year. These are all are having a basic knowledge you are already known before this session. Now coming to that is a actual our topic, that is a uh, third concept, that is a differentiation. Before defining the or knowing the meaning of differentiation, we must know about quantity. Quantity means anything which undergoes addition, subtraction, division, multiplication, etc., called quantity. Therefore, we say that is anything which undergoes addition, subtraction, division, multiplication, etc., are called quantity. Quantity may be constant or variable, where a quantity whose values remains constant is called constant quantity, and a quantity whose values will be a changes called that is a or vary, it is called as a variable quantity. Again, constant quantities are two types. One is called as a absolute constant, another one is arbitrary constant quantity. A quantity whose values remains constant in all situation, in all problems, called that is a absolute constant quantity. And example is nothing but a real gas constant R is equal to 8.314 joules per Kelvin per mole. This R value is remains constant in all situation, in all problem, that is called as a absolute constant. Whereas a, a quantity whose values is constant, remains constant in particular situation or particular problem, but its value is changing from one place, one problem to another problem, that is called as a arbitrary constant. For example, taking the integration, of constant, we will get that is a, we are apply that is a c value, that is called as a c no, that is called as a arbitrary constant. And value of c in that particular problem will be different from the value of that arbitrary constant in other problem. Therefore, the problem to problem, that value will be changing but remains constant in that particular problem only, but it is changing from one problem to another problem. That is called as arbitrary constant. Now coming to the variables, a quantity whose values changes, that is a changes, are variable, that is called as a variable quantity. Where variables are two types, one is called dependent variable, another one is called as a independent variable. Therefore, independent variables means a quantity whose values is not depend on other, called that is a independent variable. Again, the dependent variable means a quantity whose values is dependent on the value of other is called dependent variable. Therefore, these are the two types of the variables are there. Dependent variable, another one is independent variable. Now coming to that is the function. What is mean by function? If a relationship between or a relation between dependent and independent variables is called function. The relationship between dependent variable and independent variables are called function. It is represented as y is equal to f of x. This is called as a function. Function means here y is nothing but dependent variable and x is nothing but this is the independent variable. Therefore, relationship between dependent variable and independent variable called that is a function. When a variable changes its value of a small quantity is called as a increment. If suppose we have to allowing that is a change in x value, small change in x value, that will be called as a variable or it is called as a increment, and it is represented as delta x. Now where consider the function y is equal to f of x. This is the function because it is a dependent variable and independent variable, and this is the relation will be equal to there, that is called as a function. Call equation number 1, where x is independent variable and y will be a dependent variable. Let delta x be the change in f of x, corresponding to delta y will be a change in y, because x is independent variable. Therefore, x will be a changing as a delta x. Therefore, y will be depends on the value of x. Therefore, y also changes as a delta y. Therefore, the equation will be a, it is a first equation changes into 2 means y plus delta y equal to f of x plus delta x. Call equation number 2. Then subtract equation 1 from 2. Therefore, we will get that is a y get cancelled. We will get that is a delta y. No, subtract equation 1 from equation 2. We will get that is a delta y is equal to f of x plus delta x minus f of x. Divide this equation by delta x. Therefore, we will get that is a delta y divided by delta x equal to f of x plus delta x minus f of x dx delta x. Taking limit delta x tend to 0 on both sides, then limit of delta x tend to 0. Delta y divided by delta x is equal to limit of delta x tend to 0 of f of x plus delta x minus f of x delta x. If the limit is called, that is the derivative of y with respect to x. If limit is exist, therefore how it is defining in a systematic manner as a differentiation means you have to letting x is equal to f of x, then change in x value, then we will get that is a taking limit whatever may be. Then if limits is exist means you will get something value, then it is called as a derivative of y with respect to x, and it is denoted by the symbol dy by dx. Then the process of finding dy by dx for any function is called differentiation. The process of finding dy by dx for any function is called differentiation. Now coming to that is the rules for finding the differentiation. If y is equal to u plus sign minus v, where u and v are functions of x. Then dy by dx is equal to du divided by dx plus sign minus dv divided by dx. And this rule is called as a addition and subtraction rule for differentiation. Then coming to that is the second function. The second rule, if y is equal to u into v, it is a product of two functions, therefore it is called as a product rule. Therefore, where y is equal to u into v, where u and v are the functions of x, then dy by dx is equal to u keep as it is, dv by dx plus v as it is, take that is a differentiation of du by dx. Therefore, suppose this is first function, this is the second function, keep the first function as it is, take the differentiation of second function, plus keep the second function as it is, take the differentiation of first function. Therefore, keeping first function as it is, taking the differentiation of second means dv by dx, plus keep second function as it is means u keep as it is and take the differentiation of first means du by dx. This is called as a product rule. Then third rule, this is the if y is equal to u by v, u is nothing but first function, v is nothing but second function, where u and v are that is the functions of x, and this function is called as a this rule is called as a quotient rule. Now differentiating now with respect to x means dy by dx. Now here for that, take the in the denominator second function square, means v square you have to take, and then in numerator keep second function as it is, take differentiation of first function, and compulsorily you keep minus, then put first function as it is, take the differentiation of second function. This function is, this rule is called as a quotient rule. Now here simply first function is nothing but u and second function is nothing but v, therefore v square will be there. The second function as it is means you keep v as it is, take the differentiation of first function means du by dx, keep minus as it is, then keep first function as it is means u as it is, take the differentiation of second function means dv by dx. Now this rule is called as a quotient rule. Then fourth rule is nothing but if y is equal to k into u, where k is constant and u is a function of x, then dy by dx is equal to k you have take as outside and make that is the differentiation of du by dx. And this is the just constant into single function, that is called as a this is the another rule, that is the fourth rule. Now knowing these four rules, we have to solve some problems, and simple problems will be kept for in chemistry syllabus. Therefore you have to practice these problems only. These out of these problems, one or two problems will be compulsory in examination. Therefore we have to solve find the differentiation dy by dx of the following function with respect to x. First problem is nothing but e to the power of x. Second function is log x. Third problem is sin x. Fourth problem is cos x. Fifth problem is 1 by x. Sixth problem is x square. Seventh problem is x to the power of n. Eighth problem is root x. And ninth problem is x to the power of x. These are the 9 problems kept for that is a syllabus for you people. Now come to that is solution for first problem. For taking the, you have to write in equation manner, let y is equal to e to the power of x. You know that formula, dy by dx is equal to e to the power of x is the answer. Okay, you have to write just simply let y is equal to e to the power of x, then dy by dx is equal to e to the power of x. That's all you get, that is the answer for this problem. But I can write that is systematically how it's got that is e to the power of x in that is a systematic manner. You can write, otherwise you don't write, but dy by dx means e to the power of x. It is sufficient answer for this problem in chemistry. Now just I have to give how it is e to the power of x getting, that can be explained taking log on both side here. Therefore it got that is a log y is equal to log of e to the power of x. Then you have to write that is log x, log y is equal to, again you have to apply that is formula log of m to the power of k means k log m. Therefore, x log e. Again here, log e is nothing but it is a 1, because logarithm to the base itself is 1. No, that is a one, that is property we have learnt in first session of this mathematical concept. No, logarithmic relations, in which logarithm to the base itself is 1. Therefore, log e is nothing but 1. Therefore, you have to write that is a log y is equal to x. Now taking the differentiating this equation with respect to x, then log y means 1 by y, dy by dx is equal to x is differentiation is 1. Then dy by dx is equal to, you have to transfer this y that side, therefore it will be became a y. Therefore again you have to re-put y, you have to take an as e to the power of x. Therefore dy by dx is equal to e to the power of x. Therefore simply how I explain this comes, that is the dy by dx is equal to e to the power of x. In single steps, that answer is nothing but dy by dx is equal to e to the power of x. Otherwise you have to work out this manner, you will get that is a dy by dx is equal to e to the power of x. Now coming to that is a solution for second problem. Let y is equal to log of x. Now differentiating y with respect to x, dy by dx is equal to 1 by x. This is the directly come, you must be know about log x means 1 by x, because this 1 by x it comes from, that is again first principle method you have to work out, but you don't work out here in chemistry. Just dy by dx is equal to, you keep in mind log x differentiation means 1 by x. That is the answer. Solution for third, let y is equal to sin x. Again differentiating y with respect to x, you will get dy by dx is equal to cos x. Therefore differentiation of sin x means it should be a cos x. Just it is keep in mind, because it is how it is coming means again you have to go to, that is a first principle method to work out all, that is a theorem like no problem. You will get that is the final answer will be a sin x differentiation means it is a cos x. And solution of 4, that is y is equal to cos x means differentiating y with respect to x means dy by dx is equal to minus sin x. Minus sin x will be come. That is a simple. Here we know that differentiation of cos x means minus sin x, and differentiation of sin x means that is a cos x. This you have to keep in mind and you have to able to write. The solution of fifth, let y is equal to 1 by x. Then you take that is a laws of indices, that is the x to the power of 1. Then differentiating this equation, we get that is a dy by dx is equal to x to the power of n. No, that is that formula you have to apply. X to the power of n, y is equal to x to the power of n means dy by dx is equal to n into x to the power of n minus 1. Therefore n is nothing but minus 1. For putting this, no, we have to write that is dy by dx is equal to minus 1 into x to the power of minus 1 minus 1. Therefore it is simplify minus 1 x to the power of minus 2. Then you have to make that is a denominator. Therefore dy by dx is equal to minus 1 divided by x square. This will be after simplification, after some calculation you will get that is a dy by dx is equal to minus 1 divided by x square. Again solution for 6, let y is equal to x square. Differentiating y with respect to x, then it is the same formula, x to the power of n formula, n into x to the power of n. Therefore n is nothing but here 2. Therefore n into x to the power of n minus 1 means, therefore dy by dx is equal to n means that is a 2, and x to the power of n minus 1 means 2 minus 1. Therefore it became a 1. Therefore it is a 2x only. Therefore dy by dx is equal to 2x will be the answer. Then again this formula will be there. That is the seventh, that is a problem, y is equal to x to the power of n. This is the major problem. This is the main, that is the formula. For keeping from this formula only you have to calculate these some problems you have to solve from. This is the basic formula. Therefore dy by dx is nothing but integrating, that is differentiating y with respect to x means you have to write the n into x to the power of n minus 1. Then eighth the solution is nothing but y is equal to root x. Root x can be written as in the form of x to the power of n. No, this is the seventh formula. No, like that. Therefore you can write y is equal to x to the power of 1 by 2. Then you formula write that is dy by dx is nothing but n is n into x to the power of n. Here n is nothing but 1 by 2. N by n is nothing but 1 by 2 into x to the power of 1 by 2 minus 1. 1 by 2 minus 1 means minus 1 by 2, and that will becomes, that is 1 by 2 into x to the power of 1 by 2. Then it is a 1 by 2 means you keep that is a square root, therefore we will get that is a dy by dx is equal to 1 divided by 2 root x. 2 root x is the answer of this question. Then last problem is nothing but solution for ninth. Let y is equal to x to the power of x. This cannot be here. X, both our function are there. That should be solved by using a taking the logarithm. Taking log on both sides, you will get that is a log y is equal to log of x. Here logs is take here. Some mistake will be there. Therefore x log x, log x. Then differentiating y is equal with respect to x means 1 by y into dy by dx is equal to, this is the two functions are there, that is a product rule will be there. X is first function and log x will be a second function. Keep first function as it is, then take the differentiation of second function means taking the differentiation of log x means 1 by x, plus you put second function keep as it is means log x keep as it is, take the differentiation of first function means the differentiation of x is nothing but 1. Therefore you can write further, therefore 1 by y dy by dx is equal to, now here this x and this will x get cancelled, therefore we will get that is 1, and this is the log x. Log x will, again that is y will be a transfer to that side, therefore dy by dx is equal to 1 plus log x y. Again you have to re-put y is equal nothing but e to the power of x, therefore dy by dx is equal to 1 plus log x into x to the power of x. This is the answer for that problem. Now we so far that is solve that is some problems by using a differentiation rules. Now coming to the what is mean by maximum or maxima, maximum value and minimum value. Now a function f of x is said to be maximum at x is equal to a if f of a is greater than f of x for all values of x in neighborhood of a, an interval of the form of a minus h, a plus h surrounding a, where h is surrounding a, where h is very small, known as neighborhood of a. This is shown in figure, and that is a is called as a maximum, or that is simply we say that is how it is a simple manner defined. A function f of x is said to have a maximum value at x is equal to a if f of x is greater than f of x for all value of x is neighborhood of a. For x, all value of x is the neighborhood of a. This is called as a maximum value or maxima. That's all. And here similarly we can say that is the minima. A function f of x is said to have minimum value at x is equal to b if f of b is lesser than f of x for all values of x in neighborhood of b. This is called as a minima. Okay, we can say that is a minima. Now here usually know this is the a point is called as a maxima and b point is called as a minima. Here the at f of x is equal to f of x at a is equal to f of a is greater than f of x, because here f of a minus h and here a plus h will be there, that is greater value and lesser value, and f of x is greater or greatest at f of a is equal at a is equal to f of x is equal to f of a. It is the greatest value and other values are lower value, therefore it is called as a maximum value. And f of b, no, it is the lowest value. Here suppose going that is a b minus h, here comes that is a lower value, and b plus h means higher value of this is the x, but it is a curse that is takes place this like, but it is a lowest value, right? F of x is equal to x value, f of a, that is x is equal to b, that situation this value is the lowest value, that is called as a minimum value. And the the point will be obtained, that is a drawing, that is a tangent to the curve. This is the curve manner, and a tangent, no, a tangent is nothing but a straight line curve is touch to the circle at single point, that is called as a tangent. Okay, therefore B point is the lowest point, that is the lowest point. Here we are going to towards this, the value will be a increase a plus, that is B plus H. Here maybe B minus H, and this is the X is equal to B, it is the lowest value. Here similarly, A is nothing but A minus that is H will be there, that is H is the small value, and here A plus H will be there, but the X is equal to A means it is the highest value, that is called as a. This is the maximum and this is called as a minimum. Now coming to that is a condition for maxima or minima. The minimum and sufficient condition for a function f of x is said to be a maximum or minimum if dy by dx is equal to 0. Now it is what is the condition for maximum and minimum function? A function is said to be a maximum or minimum, then dy by dx is equal to 0. This is the minimum and sufficient condition for maximum and minimum function. Now if maximum or minimum means another, that is condition will be there. A function f of x is said to be a maximum if d2y by dx square means the successive derivative of y is at particular x is equal to particular value is lesser than 0 or negative value comes, then it is called as a minimum value, that is a maximum value. It is lesser than 0 means negative value comes at putting that is x is equal to certain value, then we say that is it is a maximum value. And a function f of y is said to be a minimum if the d2y by dx square is equal to greater than 0. That should be a positive at x is equal to certain value. Suppose we are putting x is equal to certain value, then d2y by dx square is equal to greater than 0 or it is a positive, then it is the function is said to be a minimum. Therefore, to defining that is whether the function is maximum or minimum means we take that is successive differentiation means d2y by dx square, and then you have to find out whether it is a negative value or positive value. Then positive value means it is a minimum value, if negative value means it is a maximum value. Then coming to that is the problems on this maxima and minima, that is certain problems they will be asked. First problem goes to if a function y is equal to 2x square minus 6x plus 7 is said to be a maximum or minimum, find the value of x. Such type of question will be asked in the examination. Given that y is equal to 2x square minus 6x plus 7, differentiating this equation with respect to x, then we will get that is a dy by dx is equal to 4x minus 6x by applying that is a differentiation rule. And then we know that is condition for maximum or minimum means dy by dx is equal to 0. Therefore, you have to put dy by dx is equal to 0 in this equation. Then we will get that is a, we will get 0 is equal to 4x minus 6x. Then that is 6x, it is not a 6x but 4x minus x, no, it should be a minus x only, minus 6 only, it is not x, 4x minus 6. Therefore, 4x minus 6 equal to 0. Then we have to calculate x is equal to 3 by 2. 3 by 2. It is not x here. It is 4x minus 6. Therefore, we say that is a putting that is value of dy by dx is equal to 0 means we will get that is a 0 is equal to 4x minus 6. Therefore, 4x minus 6 is equal to 0 and x is equal to 3 by 2. Therefore, the function is said to be a maximum or minimum x is equal to 3 by 2. This like question will be asked in the examination. Next, second question, one more question problem I have to solve. If y is equal to 3x cube plus 2x square minus 5x plus 7, show that the function is minimum at x is equal to 1. Now, how to solve this? Given that y is equal to 3x cube plus 2x square minus 5x plus 7. Differentiating this equation with respect to x, then dy by dx is equal to 9x square plus 4x minus 5. X is nothing but it is 1 and it is a 0. Therefore, dy by dx is equal to that is 9x square plus 4x minus 5. Again, for we have to know that is a minimum or maximum means you have to take that is successive differentiation. Again, differentiating this equation with respect to x means d2y by dx square. Therefore, it became a, what is that, 18x plus 4. 18x plus 4 will be a get, that is a d2y. Again, at the value now x is equal to 1, it is given that is the function is said to be minimum. At you have to prove x is equal to 1 means you have to put value of that is d2y by dx is equal to x is equal to 1. Then after substituting 18 into 1 plus 4 means you will get that is a 22. Therefore, since this 22 is greater than 0, since d2y by dx square is greater than 0 at x is equal to 1, hence the given function is minimum at x is equal to 1. Such type question will be asked in the examination. Now coming to that is a partial differentiation. A function of two variables is written as z is equal to f of x comma y, where z is said to be a explicit function of x and y. The variation of z with variations in independent variables x and y may be studied. Here, this partial differentiation contains more than two variables are there. Minimum, that is more than two variables, or more than two variables are positive, or more than one variables are takes place in partial differentiation, and that can be partially differentiated by keeping first function as it is, take the differentiation of another, and another, that is second one is keep constant and take the differentiation of first. That like that is the differentiation is takes place, that is called as a partial differentiation. Now here in this function, if z is nothing but function of x and y, it can be z can be changes. How it is changes? There are three options will be there. If x is allowed to vary while keep y is remains constant, then derivative of z is called partial derivative of z with respect to x. This can be denoted as dz divided by dou z divided by dou x at the constant value y, at constant y, dou z divided by dou x, that is a dz equal to, will get call equation number 1. This will be a differentiating by keeping y is constant and allowing the x will be changing, and the what is the changes takes place, that can be dz is equal to dou z divided by dou x at keeping x y is equal to constant. This is called equation number 1. Similarly, you have to another, that is possibility, keep y, okay, x is remains constant. If y is allowed to vary while x remains constant, then derivative of z is called partial derivative of z with respect to y. This is denoted as dz is equal to dou z by dou y at x, at constant x, that call equation number 2. Then third possibility is nothing but you have to allow both x and y simultaneous. One is keep constant, where y will be a change. Again y will be make constant, x will be a change. Then again simultaneously, that is simultaneous take. Therefore, both x and y vary simultaneously with respect to x and y is given by adding equation 1 and 2. Therefore, we will get that is a dz is equal to dou z by dou x y into dx plus dou z y at constant x dy, and this is called as a partial differentiation. This is called as a partial differentiation. Now coming to that is the application of partial differentiation. Partial differentiation is used in the derivation of enthalpy and Gibbs free energy equation in chemistry. Usually the applications are according to your syllabus. There are two applications are there. How the enthalpy change, partially by using a partial differentiation, and another one is how the Gibbs free energy change, that can be explained by using a partial differentiation. Now here the enthalpy change in nothing but heat content, that is H is equal to internal energy E plus PV, that is the work function, E in plus P into V, that is pressure and volume. According to partial differentiation, you can write that is a dH is equal to d, that is single function will be there, therefore it is a dE. But here two functions are there, it is a partial differentiation, it is a simple differentiation, therefore dH is equal to dE will come, plus it is a function of that is a two variables are there, one is P and another one is V, therefore keep first function as it is, therefore it is a keep constant, P keep as it is, take the differentiation of second, therefore dV, that is P dV, and plus keep second function as it is, to take the differentiation of second, therefore dP. This can be, this is the answer for that is a this is the partial differentiation. Or we can also d in place of delta, we can also written that is a delta H is equal to delta E plus P delta V plus V delta P. This is the called as a partial differentiation by using this enthalpy equation H is equal to E plus PV. Similarly, we have to differentiate partially, gives free energy that is G is equal to H minus Ts. S is nothing but entropy, the degree of randomness of the molecules in the system called that is the entropy, and gives free energy is nothing but the extra energy available in the system to do useful work, that is called as a free energy, change in free energy. Therefore change, these are the state function, and therefore we can be partially differentiate. According to partial differentiation, we can write that is a dG is equal to, again that is a dH minus, you have to minus, put minus, and this is the product of two function, one is temperature, another one is entropy. These are the two state function. Keep temperature as it is, take the entropy change, means ds is the change in entropy. Again here minus will be there, therefore you keep minus as it is, minus, then entropy keep as it is S, and take the differentiation of that is a temperature, therefore we will get that is a dt. Therefore dg is equal to dH minus T ds minus S dt. How it is minus came? Actually this is the minus, no, therefore keep that is a bracket here, and you have to T ds plus S dt, close the bracket, then you have to multiply to the bracket by minus, therefore minus TDS minus S dt will get. Therefore we can also be written as delta G is equal to delta H minus T delta S minus S dt. And these are the two applications of partial differentiation which are very much useful in the chemistry. And so far we have learnt about in this session meaning of the differentiation, you have already known. Again, rules for finding the differentiations, we have solved the problems. Then you have known meaning of maximum and minimum, and what are the conditions of maximum and minimums, we have already known. Again, we have solved some problems on maximum and minimum. Then we have also known about that is partial differentiation, the how it is partial differentiation takes place, more than one variables there, no, that can be partially differentiation takes place, therefore that can be explained. Again, what are the applications of partial differentiations in chemistry, that you have studied. Therefore I have to ask some questions, you have to answer correct answer option. Now first question which goes to, that is a differentiation of a function y divided y is equal to u by v is called A option product rule, quotient rule, divide rule, then none of these. I will give that is a 10 seconds for you people. You have to answer the correct one. B option is the correct option for this question. That is a quotient rule, because that is a second rule will be there, no. third rule will be there. No, differentiation of a function y is equal to u by v means it is a quotient rule. Therefore, quotient rule is nothing but it is the correct answer. Then second question, number of variables contained in partial differentiation. Number of variables contain in partial differentiation. First option, more than 1. B option, only 2. C, less than 2. And D is none of these. I will give that is a 10 seconds for you people. You can think and you have to answer. Answer for this question is A option, because more than 2 that is the variables are possible, because we are taking that is z is equal to f of that is x into y, means here 3, z is one variable, x is another variable, and y is third variable. Therefore, more than 2 variables are possible in the partial differentiation. Therefore, more than 2 variables takes place. And only in equation, any equation, it contains 2 variables. One is dependent variable, another one is independent variable. But here more than 2 variables are, it is considered to that is a partial differentiation. Therefore, A option is the correct answer for this question. Third question is nothing but when a function is said to be a maximum or minimum, then option A option is dy by dx is equal to 0. And then dy by dx is greater than 0. C option is dy by dx is lesser than 0. Then D is nothing but none of these. I will give that is a 10 seconds for you people. You have to answer this question. Here A option is the correct option for this question, because the dy by dx is equal to 0. A function is said to be a maximum, this is and minimum. This is the minimum and sufficient condition for a function is said to be a maximum or minimum, means dy by dx is equal to 0. Next, fourth question, when a function is said to be a maximum, then option d2y by dx square is equal to 0, d2y by dx square is greater than 0, d2y by dx square is less than 0, and D is none of these. I will give that is 10 seconds for you people. You have to answer correct one. C option is the correct answer for this question, because when the function is said to be a minimum, means the successive derivative or second derivative of that function is less than 0 or negative value, then it's said to be a maximum. If it is positive, then it is called as a minimum, and therefore if it is 0, it is not meaningless. It cannot be decide whether function is maximum or minimum. If it is greater than 0, means it is a positive, then it is called as a minimum. It is a lesser than 0, means it is a negative, then it is called as a maximum. Then fifth question is partial differentiation of g is equal to h minus ts. The partial differentiation of a function, the change in free energy is equal to heat content, that's enthalpy minus product of temperature and entropy. Now option is nothing but A option, d delta g is equal to delta h minus t delta s. Second option is delta g is equal to delta h minus t delta s plus S delta T. C option is delta G equal to delta H minus T delta S minus S delta T, and D option is none of these. I will give 10 seconds for you people. You have to answer the correct one. Answer for this question is, that is a C. C option is the correct, because the change in free energy is equal to delta G is equal to partially differentiation delta H minus of, that is the first function, take as it is, take the partial differentiation of S, therefore delta S, again here minus will be there, that will be minus come here, and second function keep as it is, take the differentiation of first one, therefore S delta T. Therefore C option is the correct answer for this question. And for preparation of this session, I have used these books as a reference. Thank you.